Okay, so good morning, everyone. This is the new chapter, or we can say a new functionality which operating system provides, which is known as memory management. And previously, from the very beginning, we discussed each and everything related with process management, how operating system manages the various processes and the concepts related to processes. We learned what is a process state diagram, process control block, how CPU scheduling is done, how process is moved from one state to another state, from RAM to CPU and CPU back to the RAM, and so on. So many interesting things we have learned previously related with the processes. We have learned the concept of deadlocks, and we have seen the concepts of process synchronization also. So that was one of the function of operating system, to manage various processes and the important concepts related with the processes. Now we are going to start another important function of operating system, which is memory management. And this module is all about the memories and how operating system manages the memory. And here the word memory will simply means our random access memory, primary memory, or main memory. Although we are having so many different types of memories, like the concept of cache memory, the concept of secondary memories. In secondary memories, we have magnetic disks, magnetic disks, optical disks, and so many things are there. But as we know that to execute any program or any process, first the program must be there in the RAM, and CPU then only executes that particular program. So this chapter is all about how operating system manages the memory. And memory, if we are talking about memory management, then this word memory will always be the random access memory, because we know in the concept of multi-programming, there are so many processes which resides all together at the same time in the RAM, so as to increase the CPU utilization. And we have learned that whenever CPU is idle, we quickly assign any one process to the CPU so that CPU utilization should be more. So how operating system manages this RAM space, हमारे पास जितनी भी memory space है उसको operating system कैसे manage करता है, how processes which moves from hard disk resides in the main memory, at which particular location the process will reside, how many processes at a time will be able to sit in the RAM at the same time, whenever any process finish its task, how that particular memory will be deallocated, that space from the RAM will be free. So this chapter is all about managing the memory space, कितने प्रोसेसेस हम रैम में रख सकते हैं, कहाँ पे प्रोसेस एग्जैक्टली बैठेगा, वो बार बार अगर प्रीएम्प्ट हो रहा है, सीपीयू के पास जा रहा है, फिर सीपीयू से वापस रैम में आ रहा है. सो this is all about this chapter to manage the space which is there in the random access memory. So just before starting this chapter, memory management, let me go back to the very first slide which we have studied in our chapter number 1, which is the storage device hierarchy. Here you can see we have different types of memory. And if I talk about these last 4, which is electronic disk, magnetic disk, optical disk, and the magnetic tapes, so all these 4 comes under the category of secondary storage devices, or we can say secondary memory. Then we have the concept of main memory, which is also known as primary memory or the random access memory. And then we have cache memory also, and then we have registers also. So this is what we have studied in our first chapter, and we already know about the memory and the storage devices. But in our memory management chapter, we will only talk about only this main memory, or we can say the primary memory, or we can say the random access memory, because CPU directly deals with random access memory. CPU do not have anything to deal with the secondary storage devices. And if I talk about a little bit, we have studied all these basics of memory, and this is major thing what we have discussed, that in the case of memory, the hierarchy is organized as according to these important parameters like the speed, the cost, and the volatility. And today also, just before starting chapter number 8, I'm just going to discuss three important parameters. One is speed, another is cost, and third is access time instead of volatility. So you already know, if we talk about this hierarchy, the speed increases as we go from bottom to top. That means registers are very fast, then we have cache memory, then we have main memory, and secondary storage devices have least speed, or if we compare with these storage devices as compared to these memory devices which are located at the top. And you know that as speed increases, the cost also increases. So that means the secondary storage devices are cheap, whereas main memory or cache memory or the registers are very expensive as compared to the secondary storage devices. So you can have an idea from your computer or your laptop specification. हमारे systems में हमेशा जो हमारे secondary storage है या हमारी hard disk है वो बहुत ज़्यादा अवेलेबल होती है. इट वॉज अर्लियर इट यूज टू कम लाइक 320 GB or 160 GB. Nowadays it is around 1 terabyte or even more than 1 terabyte, which is easily available. Reason being it is cheap. But if we talk about main memory, which is expensive, which is more costly as compared to the secondary storage devices, so you all know we have a very limited RAM available. Like in our computer system, we have 8 GB or 16 GB. So there is a huge difference. We used to have only 8 GB RAM or 16 GB RAM, but we used to have the secondary storage or hard disk in terabytes. So this is all about the difference in the cost. And why this difference is there? The very first important thing is that CPU can directly access the content from random access memory. That's why जो importance है RAM की, main memory की, primary memory की, वो increase हो जाती है. Secondary storage definitely cheap है, इसलिए हमारे पास ज़्यादा होती है, लेकिन हमें कोई भी प्रोग्राम, कोई भी प्रोसेस को रन करना है, सो फर्स्ट ऑफ ऑल हम उस प्रोग्राम या प्रोसेस को पिक करके रैम में लेके जाएंगे, देन ओनली CPU will be able to execute the instruction. So this is the overall story of speed and cost. So you know registers are the fastest, cache memory after that, then we have main memory. And if we compare the secondary storage devices from the above three, so they are slow. And as according to their speed, the cost is there. So secondary storage devices are slow, that's why वो उतने costly नहीं है, तो हम उनको डेफिनेटली बहुत सारा अमाउंट हमें अवेलेबल होता है हमारे कंप्यूटर सिस्टम्स या लैपटॉप के साथ. एंड यू ऑलरेडी नो वी हैव इन टेराबाइट्स आवर हार्ड डिस्क, बट वी हैव अ वेरी लिमिटेड रैम, बिकॉज अगर हम अपने सिस्टम के अंदर 320 GB या 1 terabyte की रैम को लेंगे, देन डेफिनेटली द ओवरऑल कॉस्ट विल बी वेरी एक्सपेंसिव. हमारा सिस्टम लैक्स में, 10 lakhs में, 50 lakhs में हो जाएगा. So depending upon the availability, speed and cost, all these things are accommodated with the system. So we have very limited RAM space, and only those important programs and processes which we want to execute are bring into the RAM from the hard disk. So this is very important concept that we will use in the entire chapter. So first is the speed and second is the cost. And third important factor is the access time. So access time means how quickly CPU can locate the instruction or the program to execute. So definitely if we are having more space, more a large memory space, it would be difficult for the CPU to locate the program or the instruction. But if we are having a lesser space or least space as compared to any other large space, then it would be much easier for CPU to execute the instruction, so the overall execution will be fast. So definitely you can see secondary storage devices costly nahi hai, they are cheap and they are available in a very large amount. तो अगर CPU को कोई भी इंस्ट्रक्शन एग्जीक्यूट करनी है, तो अगर वो 1 टेराबाइट में से उस प्रोग्राम को सर्च कर रहा है या 16 GB में से उसको सर्च कर रहा है, सो डेफिनेटली रैम में से उस इंस्ट्रक्शन को फाइंड करना इज वेरी इजी. सो these are 3 very important parameters which you must remember if we talk about the memory management. Secondary storage devices या hard disk costly नहीं है, they are very cheap, that's why they are available in very large amount, in very large quantity, but they are very slow as compared to RAM, registers or the cache memory. Primary memory की बात करें, primary memory is costly, that's why it is available in very limited space or in very limited amount. But the important thing with RAM is it is directly connected to CPU. CPU can directly execute the instructions from the RAM. That's why its importance is very much, and that's why it is very much costly. And we never consider registers or cache because they are very limited in space just because of their higher cost. So we will only deal with random access memory and secondary memory also. So if we want to run any program, first of all, we will take that particular program or process from secondary memory to primary memory, and then CPU will execute those particular things. So this is all what I just want to tell you. So just let me move back to the concept of memory management. So this chapter consists of these topics. First of all, we will discuss a little bit about the background knowledge, what we already know about the memory concept. Then what is swapping, and after swapping there are 2 different ways of memory allocation. One is contiguous and second is non-contiguous. So in non-contiguous we have paging and segmentation, which are the 2 different methods of non-contiguous memory allocation. But before non-contiguous memory allocation, we will discuss about contiguous memory allocation, which is one of the methods. So simply memory allocation means how operating system is going to manage the space of the available memory, that is RAM. So if my RAM is suppose of 2 GB, then how many processes can be there at a time, or how many processes will be there, and how at which particular place they will reside, and what will happen if any of the process is preempted or it is terminated or it is assigned to CPU. So this is all about memory management. So let me start with the background. So we all know that any program which we want to execute must be brought into the main memory from the hard disk or from the secondary storage device, and it is placed within a process. And this is very important. Main memory and the registers are the only storage devices which CPU can access directly. So that's why they are very costly and available in very limited space. So CPU directly data या instructions को कहाँ से access कर सकता है? One is the registers, and second is main memory, that is our RAM. And if we talk about registers, so registers are the fastest. As you can see, register access in 1 CPU clock or even less than 1 CPU clock, whereas random access memory can take many cycles. That means it is slower than registers, but it is still faster. And cache also is another option which sits between main memory and the CPU registers. That means cache is faster than main memory, but it is slower than CPU registers. But just because of their high cost, we do not deal with registers and cache. We always deal with main memory to execute the programs. And protection of the memory is required to ensure the correct operation. So protection here simply means अगर एक स्पेस पर एक प्रोसेस ऑलरेडी बैठा है तो कोई और प्रोसेस उसी स्पेस पर रैम में आके ना बैठे. सो दिस इज हाउ the operating system will manage the region, the space inside the random access memory. So this is the picture of the RAM. So this is just an example. So you can understand so many things from this particular diagram. So this is the diagrammatical representation of random access memory. This is RAM. And as you already know, some portion of this random access memory is always occupied by the ऑपरेटिंग सिस्टम. तो जैसे ही हम अपना कंप्यूटर सिस्टम ऑन करते हैं, सबसे पहला टास्क ही क्या होता है? बूटस्ट्रैपिंग. सो बूटस्ट्रैपिंग में क्या है? ऑपरेटिंग सिस्टम भी क्या है? एक तरह का प्रोग्राम है. तो वो सबसे पहले जाके रैंडम एक्सेस मेमोरी में लोड होता है. दैट इज नोन एज बूटस्ट्रैपिंग. एंड देन ओनली आवर सिस्टम स्टार्ट्स एंड वी आर एबल टू perform the various operations. So some of the portion will always be occupied by your operating system. So आपने हमेशा देखा होगा आपके सिस्टम में if you are having 8 GB RAM, then आपको कभी भी complete 8 GB RAM वो शो नहीं करता. It will be either 6.8 GB, 7.2 GB. What is the reason? बिकॉज डेफिनेटली हर टाइम जब भी आपने अपना सिस्टम ऑन करना है, सबसे पहले ऑपरेटिंग सिस्टम जाके लोड होगा रैंडम एक्सेस मेमोरी के अंदर. तो वो स्पेस आपकी हमेशा आपके लिए अनयूज्ड रहेगी. आप उसको यूज रहेगी, उसको आप यूटिलाइज नहीं कर सकते अपने यूजर प्रोसेसेस के लिए. तो अगर आपके पास 16 GB रैम है तो हमेशा आपको 14.2, 14.8, तो आपको कभी भी कंप्लीट रैम विजिबल नहीं होती जब आप उसको स्टोरेज में चेक करते हैं. इवन इन योर एंड्रॉइड मोबाइल सिस्टम्स यू कैन ऑल्सो चेक दैट. If you are having 4 GB RAM, it will show you 3.4, 3.5, 3.6. So this is the reason, because some portion of your main memory space is always occupied by the operating system. So either operating system can take the upper memory space, but in most cases your operating system resides at the bottom. So it depends upon the hardware support as well as on the different operating systems. So here you can see this is random access memory. Other than operating system, we have different processes which can reside in the RAM. So this is the concept of multi-programming. एक टाइम पर हम RAM के अंदर बहुत सारे processes को रख सकें, so that अगर कोई भी process जो currently CPU के पास execute हो रहा है, अगर वो input-output operation के लिए जाता है, then with the help of CPU scheduling हम as quickly as possible इनमें से एक process को CPU allocate करें. So this is the overall story of the RAM, but here we have to discuss or learn how actually the processes are executed. So we have the concept of base registers as well as limit registers. So basically हमारे पास memory है क्या? Memory consists of a large array of bytes, each with its own address. So basically जब हम बोलते हैं कि ये वाला process execute हो रहा है, तो ऐसा नहीं है कि वो प्रोसेस चल के सीपीयू के पास चला जाता है. रैम भी सीपीयू के अंदर ही है. सो हाउ एक्चुअली process execution occurs? So we just simply tells the CPU to execute the instructions which are located at this particular address. तो हमने CPU को क्या बताना है कि ये वाली instructions को execute किया जाए जो इस एड्रेस पे लोकेटेड है. तो अगर सपोज P1 प्रोसेस 0 to 50 पे है, then 50 to 100 एड्रेस पे हमारा प्रोसेस P2 है. So this is actually how the execution of processes occur. So ऐसा नहीं होता कि प्रोसेस चल के CPU के पास जाएगा फिर वो वहां से वापस रैम में आएगा. रैम is also inside the system overall. So basically when we talk that any process is executing, that means we have assigned the CPU those address location that जो भी इंस्ट्रक्शंस इस पर्टिकुलर एड्रेस पर हैं उन इंस्ट्रक्शंस को एग्जीक्यूट करना है. सो बेसिकली मेमोरी इज अ लार्ज array of bytes each with its own address, and simply CPU fetches the instructions from the memory according to the value of the program counter. So here we just have to learn the concept of base registers and the limit register. So you can see each process has a separate memory space, and to separate the memory spaces we need the ability to determine the range of the legal addresses that the process may access, and to ensure that the process can access only those legal addresses. So यहाँ पे आप देख सकते हो हर एक प्रोसेस के पास अपनी एक सेपरेट स्पेस है, और कैसे पता चलेगा सीपीयू को? हमारे पास दो अलग अलग वैल्यूज होंगी. वी हैव टू डिफरेंट रजिस्टर्स. वन इज नोन एज बेस रजिस्टर एंड सेकंड इज नोन एज लिमिट रजिस्टर. सो बेस रजिस्टर क्या करेगा? बेस रजिस्टर विल होल्ड द स्मॉलेस्ट लीगल फिजिकल मेमोरी एड्रेस. तो यहाँ पे अगर हम इस प्रोसेस की बात करें, so for this particular process, this is the base address. So just like an array, if we know the base address of an array and we know the size of each element, then definitely we can tell the location or the exact location of any of its elements. So the same concept applies here to the concept of the memory. So you can see for this particular process, we have two different registers. These are the special purpose registers, which is loaded by operating system only. So this is the task of operating system, or we can say this entire thing is done in the kernel mode. So for this particular process, this is the base address, which will be stored by the base register, and simply we have limit. So limit simply specifies the size of the range. So if I am going to add this limit value 120900 to this base value, that means the address from this up to this 420939 is contained by this particular process. तो ये वाला जो process है वो actually memory में कहाँ बैठा हुआ है? इस address location से लेकर 420939 address location तक इस process ने memory space acquire की हुई है. So this is how CPU is able to identify the location of the process and it executes the instructions as according. So this is another diagram which I will discuss later on after knowing some basic knowledge. So we have one more concept of address binding. So what is address binding? Before that, just we must know the concept of logical address and the physical address. So in the case of memory management, we have two different types of address. One is known as logical address and another is known as physical address. So very first is the logical address. So any address which is generated by the CPU is known as logical address, and logical address is sometimes also known as virtual address. So इसको virtual address क्यों बोलते हैं, इसको हम discuss करेंगे detail में in the next lecture also. And there is one more category of address which is known as physical address, which is the actual address of which is represented in the main memory. So physical address is the address which is seen by the memory unit. So we have two categories of addresses. One is logical address, which is generated by the CPU, and this logical address is generally related with the secondary memory. ये हमारा secondary memory से related है. That means अगर मेरा कोई भी प्रोग्राम या कोई भी फाइल मेरे हार्ड डिस्क में पड़ी है, and if I want to execute that particular file, then to execute that file, the CPU will have the logical address. That will be the address of that particular file in the secondary memory. But actually में वो प्रोग्राम कहाँ रन होना है? मेन मेमोरी में, रैम के अंदर. तो जब भी हम उस फाइल को मूव करेंगे सेकेंडरी मेमोरी से मेन मेमोरी के अंदर, तो उसका एड्रेस है जो वो चेंज हो जाएगा, और जो नया एड्रेस होगा, मेन मेमोरी वाला एड्रेस होगा, उसको हम बोलते हैं फिजिकल एड्रेस. तो बेसिकली हमें लॉजिकल एड्रेस से डील नहीं करना होता. लॉजिकल एड्रेस वो एड्रेस है जो किसी भी प्रोग्राम या किसी भी फाइल का सेकेंडरी मेमोरी वाला एड्रेस होता है, लेकिन किसी भी प्रोग्राम को रन करने के लिए पहले हम उसको रैम के अंदर लेके जाते हैं. तो जैसे ही वो रैम में आएगा, वहां पर उसका एड्रेस कुछ और हो जाएगा. उस एड्रेस को हम बोलते हैं फिजिकल एड्रेस. तो भाई हम लॉजिकल एड्रेस को फिजिकल एड्रेस में कैसे ट्रांसलेट करते हैं, दैट वी विल आल्सो सी इन नेक्स्ट फ्यू लेक्चर्स. सो फॉर नाउ यू कैन जस्ट रिमेंबर that they are generated by the CPU according to the location of the program or the file in the secondary memory or in our hard disk. But in actual we require the physical address, because finally CPU ने जो instructions को execute करना है वो main memory से करना है. And हम जब CPU को physical address बताएंगे कि ये वाले address से लेकर ये वाले address तक की जो instructions है वो execute करनी है, then in actual we will be able to execute that particular program. So now just let me go back to the address binding. So address binding means we have to bind or map one address into another address. So just let's see what is this. So if we talk about this diagram, you can see some of the portion is always occupied by operating system, but you can see here instead of 0000, the base address or the address starts from any other number. So the question is, it is always mandatory that the physical address will start at 0000. So the answer is no. So it is not always mandatory that the physical address of the main memory starts from 0000. It may start from any of the random number depending upon the different kind of hardware support and the operating system. And if you look at this particular diagram, there are so many different processes, steps which are involved if we are going to compile, or suppose if we want to run any C program. So if we have any source program, first of all, we used to compile that, then that particular file is converted into object module, then we use the concept of linking and loading, and after that finally we used to execute that particular program in the runtime. So if we relate this thing with the address binding, there are three different ways of representing the addresses. So basically, if I talk about source code, so source code addresses are usually symbolic, and compiled code addresses binds to relocatable addresses. तो ये सब क्या है, इसको हम डिटेल में डिस्कस करेंगे. But if I talk about address binding, so address binding of instructions and data related to those instructions can happen at three different stages. So address binding का क्या मतलब है, किस पर्टिकुलर टाइम पर हम अपने प्रोग्राम को एड्रेस असाइन कर रहे हैं. सो देयर इज अ पॉसिबिलिटी दैट हम कंपाइल टाइम पर ही प्रोग्राम को एड्रेस एलोकेट कर दें और सीपीयू को बता दें कि यू हैव टू एग्जीक्यूट दीज instructions at that particular address location. Otherwise, at load time and the best is the execution time. So according to this particular diagram, we have three different possibilities. Either the address binding can happen at compile time, or it can happen at load time, or the address binding can happen at the execution time or run time. So basically, address binding simply means mapping of one address space to another. So if we talk about the compile time, so if we know the memory location in advance or at the compile time, we know that where the process will reside in the memory during the compile time, then we can generate the absolute code. And if we do not know at the compile time where the process will reside in the memory, then in that particular case, the compiler must generate the relocatable code. So relocatable code, in this particular case, the final binding will be delayed. That means we will not bind any address up to the load time, and the last is the execution time. So if the process can be moved during its execution from one memory segment to another, then we have to delay the binding until its run time. So it is a possibility that जब भी हम उस प्रोग्राम को एग्जीक्यूट कर रहे हैं तो हम उस प्रोसेस की या प्रोग्राम की मेमोरी लोकेशन को बार बार चेंज करें, तो उस केस में हम रन टाइम पर ही उस प्रोसेस को एड्रेस असाइन करेंगे. सो दिस इज ओवरऑल मीनिंग ऑफ एड्रेस बाइंडिंग. And just let me go to the last topic for today. This is memory management unit. So we already know that there are two different types of addresses. One is logical address, which is generated by CPU, but that is a virtual address. Actually, we always have to deal with physical address. And this is important line. Logical and physical addresses are same if we have address binding either at compile time or at the load time. But if we are going to assign the addresses at the runtime, then definitely these physical addresses and logical addresses will not be identical. They will definitely differ. And what is logical address space? Logical address space is the set of all the logical addresses generated by a program. and physical address space is the set of all the physical addresses generated by a program. So this is just simply the collection of all the addresses. They are known as logical address space or physical address space. So just moving on to the last topic, memory management unit, which is known as MMU. So basically CPU always generates virtual address, but we have to translate or we have to map that virtual address to physical address for the main memory, and this particular task is performed by a hardware device which is known as memory management unit. And there are so many different other ways also to convert or to translate the virtual address to the physical address. So we will discuss all these things in detail in the next lecture. And okay, we have one more concept of swapping. So swapping simply means to take the process out from the main memory and to put back into the hard disk or the secondary memory. And whenever needed, we always bring that particular process or program back from the secondary memory to the main memory. So a process can be swapped temporarily out of the memory to a backing store. So backing store simply means secondary storage devices, and then brought back into the memory for the execution. So backing store is simply a fast hard disk which is large enough to accommodate the copies of all the memory images for all the users. And this is the simply roll out, roll in swapping variant, and we can just swap the processes based upon their priority. If we have any higher priority process, it must be swapped in first to the RAM and it must be loaded and executed. And if we have any lower priority process, it must be swapped out of the RAM. So this is the overall process of swapping. And one of the major part of swapping is its transfer time. तो हमें कितना टाइम लग रहा है स्वैपिंग करने में या स्वैप आउट करने में, जब भी हम किसी प्रोसेस या प्रोग्राम को सेकेंडरी मेमोरी से रैम में लेके आते हैं या फिर हम रैम से उसको वापस सेकेंडरी मेमोरी में लेके आते हैं. So for this particular swapping concept, the system maintains a ready queue of ready to run processes which have the memory images on the disk, and on the basis of that queue, the processes are swapped in. So the modified versions of the swapping are found on many new systems. So this is, you can see the diagrammatic representation of swapping. So this is RAM and this is our secondary storage device or hard disk. So some of the portion of the RAM is always occupied by operating system, and rest of the space is for the user space or the user processes. So here you can see we have swapped out one of the process P1 and another process P2 is swapped into the main memory. It may be just because of higher priority, or it is more important to execute process P2 at the current situation. So this is how the overall swapping concept is there. So this is all for today's lecture, where we have discussed about the basics of memory management,